Here is the summary of this video. What is the issue? Lorentz transformations are the foundation for relativity theory calculations, such as the gamma factor, kinetic energy, and the addition of relativistic velocities. If the derivation of the Lorentz transformation was false, the theory of relativity would collapse. In this second video, we will critically examine the start of the demonstration with the link between x and x prime. Previously, in the previous video, we saw that these were special reference frame S and S prime, where the origins of place and time coincide. In addition, the demonstration only concerns a light wave emitted at O and O prime at the instant t equals t prime equals 0. In the usual demonstration, y prime is equal to y. During our analysis, we were unable to establish this equality. Derivations. Besides, some demonstrations avoid this subject of displacement in space by treating only the case where the photon moves only along the x-axis. That's what we're going to examine, along the x-axis. Thus y and y prime, z and z prime, are necessarily equal to 0.
Therefore, before Einstein, I would say x prime is x minus ut. And you would say x should be what you think is a coordinate plus ut. This is just going back and forth from you to me. And you can already notice that to go back and forth from you to me, we just change the sign of the velocity. Because I'm going to the right, then you're going to the left. That's why the formula is a sign of u reversed. What is the big change after Einstein? First is, I admit the possibility that maybe you will think the time elapsed since we synchronize our clocks is not necessarily the same.
Hey sir, there's trouble. How can you add the symbol prime to the Galilean time t? But let's continue.
So in particular, you will say, I don't buy your prediction that I expect to get the answer to be x minus ut. I'm going to put a fudge factor, gamma, which I don't believe your lengths are really my lengths, but I'm going to put the same fudge factor, gamma.
To do it, we have to use these equations.
So now further moving on, we have the transformation between x and x dash is of the form x dash is equal to k x minus vt.
So Lorentz consider that this relation is written as is equal to lambda into x minus vt. We can rewrite this expression as x is equal to lambda x dash plus vt dash.
As we can see from figure that from s dash, x is directly proportional to x minus vt. In the Galilean transformation equations, it was x dash equals to x minus vt. But here it is proportional to x minus vt because here the velocity is comparative to the speed of light.
To put a fudge factor, we have to use Theses equations. Transformation is of the form. The Lorentz equations considers that, as you see, these are statements, there is no argument. What they do, they say that the Galilean equations are not valid, but they still take them as a starting point. It is surprising. Then, they modify them by adding the gamma factor. And they will of course arrive at the Lorentz equations. It is not a valid derivation. Let's look at another demonstration.
Now we already know that if you just use the Galilean transformation, then the speed of light would not be absolute. It would not be the same in every frame of reference. And so we had to let go of the constraints that time and space are absolute. And so there's going to be some type of scaling factor involved. And so we can call that scaling factor gamma. So we could say, all right, let's just postulate that there's going to, that x prime, if we assume the speed of light is absolute, is going to be some scaling factor gamma times x minus vt. Well, you could make the same argument the other way around. If you view it from her frame of reference and you're trying to translate into my coordinates, you could say, well, x, instead of just using the Galilean transformation, that x is going to be equal to x prime. And now instead of a v, we have a negative v, right? So if you subtract a negative v, in fact, let me just write it that way, x minus negative v times t prime, that would be the Galilean transformation. But whatever scaling factor we used here, there's a symmetry here. I shouldn't have to use a different scaling factor if I assume a different if I'm in a different frame of reference. So if we assume the absoluteness of the speed of light, we're going to have some other scaling factor just like that. Or we
Criticism. Step 1. He starts from a Galilean equation. Step 2. This Galilean equation at x prime is equivalent to this equation at x. Step 3. He modifies the Galilean equation with the coefficient gamma of proportionality. Step 4. He thus obtained the first Lorentz equation, of course. Step 5. The equation modified in x prime is equivalent to this equation in x. Step 6. After he takes the symmetric of the drawing on the left, we get the drawing on the right. It reverses ct and ct prime. Then he swaps x and x prime. But they're not the same axes, they are not oriented in the same way. They are oriented in an opposite way, which was not the case for ct and ct prime. And then he adds a proportionality coefficient. And this coefficient is the same as before, whereas they are not the same drawings. It does not work. Results. We have failed to establish these equations between x of the reference frame S and x prime of the reference frame S prime. This stems from the fact that these x and x prime equations are paradoxically established from the Galilean transformations which are disclaimed. That then these equations are corrected without well-established justification by the Lorentz factor. And that finally the only justification sometimes given would be a symmetry which does not exist in the drawing. And you, what do you think?